We wake up, flick a switch, and command invisible currents of electrons to light our rooms. We mix industrial chemicals to wipe down our counters. Every day, we casually command highly volatile physical and chemical reactions inside our own homes, completely blind to the mechanics actually making them happen. The physicist Gerald Walker explored this exact disconnect in his book, The Flying Circus of Physics. Walker recognized that we tend to treat science as an academic subject trapped in laboratories, when in reality, ordinary life is a playground of extreme, mind-bending physics. His book catalogs how the laws of motion and thermodynamics dictate everything, from the way a coffee cup cools to bizarre historical anomalies, like the physical forces required to stop a B-25 bomber when it crashed into the 79th floor of the Empire State Building in 1945. We develop a localized, common-sense intuition to navigate the world. We assume we understand basic concepts like how to make an object hot or how to keep it cold. But when you examine these tasks on a molecular level, our intuition is almost entirely wrong. By putting 3 mundane household chores under the microscope, we can see that your house is actually an active laboratory of invisible molecular chaos. Step outside in the middle of a brutal winter. You grab a handful of rock salt, scatter it across a slick sheet of ice, and watch the ice slowly melt away. The common assumption is that the salt somehow generates thermal energy to melt the ice. It does not. The salt provides zero heat. What actually happens is physical displacement. The salt dissolves into the microscopic layer of liquid water that sits on top of the ice. It breaks apart into individual sodium and chloride ions, and these tiny particles physically wedge themselves between the water molecules, actively blocking them from linking up into a rigid ice lattice. Chemists call this freezing point depression. The chemical interference forces the water to require a much lower temperature to achieve a solid state. Salting a driveway is an act of structural molecular sabotage that bends the rules of freezing to keep the water liquid in a sub-zero environment. Move into the kitchen. You take a plate of cold leftovers, drop it into a box on the counter, press start, and 2 minutes later it's steaming hot. That box relies on a device called a cavity magnetron. It was developed by British and American engineers during World War II to generate short wavelength pulses for high-powered military radar systems. In 1947, Raytheon realized the heating potential of those radar waves and repurposed the technology into the first commercial kitchen appliance. It stood 6 feet tall, required active water cooling, and cost the equivalent of $43,000 today. There is a persistent myth that this machine cooks food from the inside out, or that it relies on a magical resonance specific only to water. Neither is true. The oven uses dielectric heating. It blasts your food with electromagnetic radiation at a frequency of 2.45 gigahertz. The food is full of polar molecules, like water, fats, and sugars, which have a positive charge on one end and a negative charge on the other. As the oven's electric field rapidly alternates, it grabs these polarized molecules, forcing them to flip and align with the shifting field billions of times a second. All of those molecules frantically grinding against their neighbors creates intense microscopic friction. Because these specific radar waves are relatively short, that friction is deposited almost exclusively in the outer 1.5 inches of the food. Using a microwave means subjecting your leftovers to rapid-fire electromagnetic manipulation. On the stove next to the microwave, you drop a raw steak into a cast iron pan. The meat immediately sizzles, turning a deep brown and releasing a heavy, savory aroma. Boiled meat tastes entirely one-dimensional, but pan-seared meat is incredibly rich. People frequently call this process caramelization, but caramelization involves the breakdown of pure sugars. Meat requires an entirely different mechanism. You are watching the Maillard action. It only triggers when the surface of the food is dry and the temperature pushes past 140 degrees Celsius, or 285 degrees Fahrenheit. Under that high heat, the amino acids from the proteins and the natural reducing sugars inside the meat collide, shatter, and rapidly recombine into hundreds of entirely new, complex molecular structures. These newly forged compounds produce distinct effects. Melanoidins give the meat its dark brown color. Pyrazines emit the nutty, roasted aromas. Thiazoles deliver the deep, savory umami flavors. Searing a steak is an act of high-speed chemical synthesis that creates the exact molecular compounds human evolution hardwired us to crave. The driveway, the microwave, and the stove are unified by a single reality. The chores we complete on autopilot rely on the literal manipulation of atoms and electromagnetic fields. We spend most of our lives using tools as black boxes. We input an action, and we expect a result. But peeling back the casing of the world to see the harsh molecular mechanics underneath doesn't drain the magic out of everyday life. It reveals a hidden layer of infinite intricacy. The next time you cook dinner or clear a sidewalk, remember the physics operating beneath your fingertips. The flying circus is always running in the background. You just have to realize you're the ringmaster.